Alright, here we go. So today we're doing integration by something called partial fraction decomposition. The idea of partial fraction decomposition, roughly speaking, is to unadd fractions. The simplest case might be something like this. Suppose I have something like, let's go here. Suppose I have something like 2/3 plus 1/5. If you were given this in grade school, you might be asked to add the fractions. You would get a common denominator. Maybe do 2 times 5 over 3 times 5 plus 1 times 3 or 5 times 3. That way they both have the common denominator of 3 times 5. So you would get something like 10 over 3 times 5, that's 10 over 15, and a 3 over 3 times 5, for a grand total of 13 over 3 times 5, or if you like 3 over 15. That's how you add fractions. Now in the world of integrals, back in grade school you might have been told that this is a simpler form, this is simplified, or this is simplified. It would have told you never leave it like that. Actually, that's only part of the story. It turns out that later on in life, such as now, in the world of integrals, this becomes a lot easier than the so-called simplified version. That actually becomes a lot harder. And so the idea is to try to unadd the fractions. When you can unadd the fractions, you can actually make the problem 1,000 times easier. So it would go something like this. Somebody might give you that fraction. Maybe they erase everything else before that, and then maybe they ask you, hey, can you unadd the fraction? If I have 13/15ths, how many 13/15ths, they can ask you how many thirds is that and how many 15ths is that. That would be a way of unadding the fraction. If you could solve these numerators, you could solve it, and you could say, well, I've got 13 over 15. Then you start to work your way backwards. Yeah, I meant 5 here. How many this is a B. How many fifths is that and how many thirds is that? That would be, if you can solve that, you will have unadded the fractions, and that's the key to this idea. We could do this one here because it's easy enough. It'll just take us a second. If you have a over 3 plus b over 5, you could multiply everything by the least common multiple, giving you that 5a plus 3b is equal to 13, and then you go on and you try to find solutions that fit that equation. I think, for example, there might be more than one solution that works here. There usually is a lot of them, but sometimes any one of the solutions that you find will be good enough. In this case, for example, you could have a 2 there, that would make 10, and a b could be equal to 1, and that would make 13. And although I'm just guessing here by eyeballing it, we'll have more methodical ways of doing it in just a second when we do it for polynomials on integrating. Once you solve this, you will have taken your fraction here and said, hey, this is equal to 2/3 plus 1/5, and that would be a better way of working, better way of writing this expression, easier to work with when we're talking about integrals. That's the main idea. All right, come back and we'll do an actual example, or a few. We'll see you here in a second.